I just finished a video on Chapter 7, the first three questions, I believe it is, that we did in Chapter 7 homework, short answer homework, 7, 2, 4, and 6, or 7, I'm sorry, 2, 4, and 7. They were all related to unemployment. Now I'm going to do questions 7, Chapter 7, number 11, 12, 13, 15, and 16. Except for 16, which actually I think would be better with the next chapter, but that's fine. These are related to inflation. So here we go. Consider the following price indices 90 in 2017, 100 in 2018, and so forth. Those numbers by themselves have very little meaning. They need context of being relative to each other, basically, to have meaning, with the exception of one having a specific purpose there. And that's what A answers. Which year is likely the base year? One of those numbers does have some meaning in our discussion here about price indices. It has meaning by itself. The price index, whatever kind of price index we're talking about, in the base year is always what? 100. So which year is the base year? It is 2018. Why? Because in 2018 the price index was 100. Or think it through. Why would it be 100? Because the price index is nominal over real, or the market value of the basket of goods over the same basket of goods value in base year prices. Well, in the base year, the market value and the base year prices are the same prices. So you're talking about something divided by itself, which is always 1. And we multiply all these things by 100, and 1 times 100 is 100. So 100 is always our base year index for any kind of a price index. B, what is the inflation rate from 2018 to 2019? This one's too easy because it doesn't show you anything. We can look at those numbers. If a number went from 100 in 1 year, whatever the number is, here it's a price index. When it went from 100 in 1 year to 110 the next year, how much did it rise? We're always talking about in percent terms. It rose 10%. That's too easy. Look at the next one, and I'll go ahead and write it on the whiteboard. What is the inflation rate from 2019 to 2020? Same question, different years, but more importantly, numbers that most of us wouldn't figure out in our heads. So we have to know how to do percent change. That's all we're asked to do. It says what's the price index or what's the inflation rate. The inflation rate is the change in percent terms of the price index. That's what the price index does for us. It shows us what inflation is by going from year to year and finding the percent change. What's percent change? New minus old over old. So now let's fill in these blanks. New minus old over old is percent change of anything, anytime, anywhere. So from 19 to 20, in 2020, the number we're interested in, this price index, the new was 121. 121. The old was 1 in 2019, 110. This is new minus old over old, 110. I see 11 in the top over 110, and I think that is, if I am using my head correctly here, and I'm trying not to look, at 0.1, which is therefore 10%. I think 10% is, again, let me make sure I haven't made an arithmetic kind of error here because I'm just doing this on my head. And yes, I got 10% when it is right. Didn't make any boo-boos there. So for A and B, inflation was 10% because the price index changed 10%. This is letter B. A, I just did it out loud with the same process. 110 minus 100 over 100. That's 10 over 100, which is also 10%. So that's A and B. And then, no, I'm sorry. A was just the base year. So that was B and C. That was B and C. B and C, sorry. I forgot. One thing I answered verbally already was the base year. This was letter C. B, I just did out loud. Okay? All right. D, if the cost of the market basket in 2018 is $2,000, So we only have what the price index was with those numbers. We don't have what it might have been. And by the way, this thing says the price index, but if the basket of goods represented all prices, well, it could have been the price of anything. Could have been the expected price of I don't know, a high-end laptop. That would be about this, right? And we could use this information to answer this about a high-end laptop. So again, if the cost of the market basket in 2018 is $2,000, what's the cost of the same market basket of goods and services in 2017, in 2021? Well, if I look up there in the question, it says the price index was 90 in 2017. Now, if it's in the base year, it's 100. That was 2018. It was 90 in 2017. So what that tells me is that the prices were 10% lower in 2017 than they were in 2018, because 90 is 10% lower than 100. Does that make sense? So if the price of what we're interested in for letter D was $2,000, then and prices were 10% lower a year before, then we're just talking about 0.9 or 90% of the same prices from 2018 were what they were in 2017. And that, I believe, is $1,800. So if you know that this price index base year was 2018, and actually the MacBook that I'm recording this with was $2,000 almost exactly. I didn't buy it. I couldn't afford that. UMBC bought this for me as a prize. I won an award there, and I got a laptop. Proud I am. And if a year before prices were 10% lower and this laptop had been well represented by the CPI, then that would mean that a year before it would have only been 90% as much, or it would have been $1,800. So we could apply it to a single good, assuming that the basket represents the general price rise of the time period. And that the single good isn't something exceptional either. So then for the next piece, let's see, I did D, in 2021. D says that's just 2017. In 2021, the price index was 150. What's the relationship between 150 and 100? Now, most of us see that in our heads, but let's go ahead. Okay, how much did prices rise from the base year of 2018 to 2021? The index can tell us that. This was an annual inflation rate because it was 1 year. The new was 1 year minus the year before over the year before. Well, now we're just looking at a 5-year period. So the new is 150. The old, because we're going from 2021 back to 2018. So new is 150, old was 100 because that's what it was. In 2018 over 100, that's 50 over 100. And we all know that's 0.5. So in the 5-year period, is that what it is from? No, not 5-year period. It's from 3-year period. So somewhere or another, it must have really jumped. It did. So over the longer period that we're looking at, from 2018 to 2021, prices rose 50%. So how do you raise something by 50% mathematically? You know, I mean, you can do it in your head. We could do it in our head, and it's probably easier. But let's go ahead and let's first do it in our head, and then let's do it mathematically, because maybe it's not always going to be as easy as 50%. If 1,000, or I'm sorry, if 2,000 was 50% greater than it is now, in 2018 it becomes 50% greater by 2021. Well, 50% of 2,000 is 1,000. So we know the answer we're looking for is 3,000. How do we do that mathematically? When you're increasing something by a percentage, you add 1 to the percentage. And that's probably part of why my tendency is to look at this and treat it like a percentage, even though it's a decimal. Because what I'm going to do is 1.5 times that base amount of 2,000. That's how you raise something by 50%. This is the something, this in this example, 2,000. We add 1 to it to raise it, because you have to raise it by the percent, and you have to keep the original amount. 1 time multiplying something by the 1 keeps the original amount. Adding to that the 50% raises the original amount by 50%, and of course 1.5 times 2,000 is 3,000. So that's, when we think to ourselves 2,000 raises by 50%, we just do it in our heads. But it's important to know what we're doing in our heads, and that's what it is. It will serve you well in life to know that when you decrease something, you multiply it by 1 minus the amount of the decrease. When you increase something, you multiply it